And this test bed will enable testing of any 5G products at system and subsystem level. So today, just to get the more details that what are the various facilities available at various institutions and how can they best make use of, we have arranged this presentation by our distinguished, in fact, CEO itself of the CEWiT, Mr. Babu Narayanan. He will be there. He is Chief Technologist CEWiT, but he will be giving the summary and conclusion. And we will start with the Professor Mythili. She is from IIT Bombay, so she will be first doing the presentation, and subsequently it will be the Anusuya. So with this, I think I welcome our Indigenous 5G testbed team for making their presentation and handing back to Mr. Uday and the other team of Nachappa. So back to you.
Thank you, Pathak ji. Thanks and good morning to you all again. Just to begin, I mean, this is going to be a very exciting session, I'm sure, after a while, after we had some series of webinars. So thanks for all the mentors who have joined in today. If you would like to as indicated by Patanji, Mr. Babu, if you would like to take the floor and address the team here. If you have any presentation, then do let us know. Then you can share your screen as well.
Okay. Yeah. Sorry.
No, Mr. Babu, you go ahead. You go ahead.
Okay. Yeah. Sure. Okay. So thanks, Pathak ji. Thanks, Uday. So as Mr. Pathak ji mentioned, we have a 5G testbed indigenously built in collaboration of 8 institutes in India, leading institutes, including CEWiT, which is an R&D entity within IIT Madras. This project is more nearing towards completion and will be ready for opening up to for usage to the Indian community, 5G community, in the next few months. In the meanwhile, it is required that we can open up for hackathon users. And for that, what we had initially looked at is that with whatever is ready as a end-to-end testbed, we can open up certain functionalities, though things are actually work in progress. But I'm sure that we'll be able to support and help all in terms of using this testbed and making use of it to demonstrate use cases, 5G use cases. So what we plan today is to have an introduction from Professor Mythili from IIT Bombay. Then Anusuya will take you through in detail of the testbed and how we can connect to the testbed as an external or a third-party user. And then I'll summarize towards the end of it. So first I'll request Mythili to give an introduction to this testbed from an overall perspective.
Yeah, thanks, Babu. So can I share my screen with the presentation?
Yes, let me just check, yeah. And then if you can just let us, my screen. Yeah, we can see.
I hope it's visible, right?
Yes.
Okay, so should I go ahead and start?
Please, thanks.
Okay, thank you. And good morning, everyone. My name is Mythili. I'm a faculty member at the Department of Computer Science in IIT Bombay. And I'm one of the institutes that is part of this 5G testbed project. And we hope that this testbed will be useful to the 5G hackathon participants in order to test their solutions. Right, so this is a brief overview of the testbed project. So this has been funded by the Department of Telecom for the past 3 years. So we are a few months away from the end of the project and having the final testbed ready. And the aim of this project was to nurture the 5G startup and research ecosystem in India, right? So that we do more R&D in the space of 5G. And the basic idea of this testbed is that it is an end-to-end testbed built from the ground up. From scratch, most of the components have been developed in-house so that we have all the source code and all the background available in order to innovate and perform R&D on the various subsystems in 5G. So this has been a collaboration across 8 institutes, and which are Sameer, which has been doing antenna design. Then there has been a team on the radio side building the UE and the G Node B, which is led by IIT Madras, IIT Kanpur, Hyderabad, CEWiT, and IISc. So the speakers today, we are primarily from the 5G core team. We have built the wired part of a 5G network, the 5G core, as well as an emulator to go along with it, which can be used by the testbed participants. And there is also some work on interworking with Wi-Fi, with non-3GPP radio access technologies, as well as some applications that have been developed as part of the testbed. So this is a overall end-to-end view of the testbed. So the UE, or the user equipment, has a bunch of applications that connect to the testbed. So you can either connect over NR to a G Node B, or you can connect over Wi-Fi through a component known as the N3 IWS. And other than these two wireless links, you can also connect through the RAN emulators, which basically emulates all of this, emulates the UE and the G Node B. If you don't want to go over the wireless, this is also an alternative. And all of these connect to the 5G core. And this 5G core consists of various components that I'm going to come to in a little bit. And through the 5G core, you can connect to external networks. And the 5G core also has where applications can be deployed for various functionality. It also has hooks for applications to be deployed. So this is the end-to-end testbed that is being developed as part of this testbed project. So just a brief overview of the 5G core and the kind of functionality that is available from our teams. So the core basically connects the UE and the radio access network to external networks, right? So the core consists of several control plane components as well as a data plane component that forwards data. And so all these acronyms are not important if you're not familiar with them, but a high level idea is the core is what sits between the base station and all the other external networks. And some of the functions that the core right now supports are users can register and deregister themselves. Users can set up sessions, modify, release the sessions, all the logic pertaining to session management. And most importantly, on the data plane, forwarding user traffic from the base station to external networks via GTP tunnels, and managing, state transitions, like when a mobile phone goes idle, becomes active again. All of these state transitions are also handled. And in a future upcoming release in the next few months, we are also working on handling mobility, things like QoS, network slicing, edge computing, which are all the novel features of 5G. All of these are also being supported in the testbed, and they will be available very shortly. So what we don't support are things needed for like a commercial deployment, like billing, charging, or full-fledged policy or roaming. That has not been the goal for this testbed. And the components that we've built that we're going to talk about today, the RAN emulator and the 5G core, have all been built in a cloud-native architecture with as software functions that run on commodity hardware. So if you want to use or leverage any of these, you don't need specialized hardware, just regular servers will do, say something like x86 servers. And these components can run either on bare metal.
Presentation is on financial prediction using data mining. I'm using a particular model to predict some financial information, which is in the aspect of.
Sorry about this. If someone is having dual screen open, if you can please mute. Thanks. You can continue.
Okay, thanks. So these components can be run directly on servers or on VMs, containers, and they've been built with the best cloud architecture principles like fault tolerance and scalability in mind. And our RAN emulator and core, they're all 15.2 release compatible. And we also have state-of-the-art technologies like DPDK used, which is like a framework that is used to give high data forwarding performance. So we can forward data up to speeds like 40 Gbps on the testbed. And the performance also is multi-core scalable. So we can get high performance by adding more CPU cores. So overall, the RAN emulator and the core are focused on high performance and can be used to test high performance workloads. We also have a state of, so you can test this, you can use this setup in two ways. One is directly with the RAN, the G node B, or connect over NR to G node B, or connect over Wi-Fi to N3 at IWF, and the UE has all the applications. And this data goes through the core, through the control plane and data plane of the core, onto the other application servers, which can be on the internet or specific servers connected to the core and so on. And we also have support for edge computing that's coming up in a future release. So this is one way to use the setup through the wireless interface. And the other way to use the setup is through the RAN emulator. If the wireless part of the testbed is not important, then for more reproducible results, you can use the RAN emulator. So this RAN emulator emulates the logic of a UE and a G node B, right? And it exposes interfaces to which different applications can be connected. And these interfaces are the same as what you would have in an actual UE or the RAN. And you can run through the RAN emulator, the core, and connect to external servers, much the same way like you would in a regular 5G network. So the next speaker, Anusuya, is going to talk about the RAN emulator and how you can use it in more detail. So that is all I have for now for the overview. Any questions? Should we take questions now or later?
Yeah, thanks really for that. I would request maybe if people have questions, you can put it in the chat, and maybe me and Natapa or if someone would address them. Mythili, you are going to be around, Mythili, during the session now. If we can keep sessions at questions at the end as such.
Sure. I'll be around. Yes.
Okay. Thank you. Thanks. I think that's very exciting to know the whole overview about the 5G testbed which has been created, and sure, people would participate a lot and leverage this very unique stuff which is so critical. And I would request now Anusuya to take her session. Thank you.
Yeah. Good morning, everyone. So am I audible?
Yes, you are.
Yeah. Is the screen also visible? Like you're able to see?
Yes.
In the PT mode, right?
Yes.
Yeah. Thank you. Thanks, Mythili. Thanks for the introduction that was given. So taking it further from wherever Mythili has left. So in this part of it, we will go in detail about what are the various use cases that you can try over this thing. This overall architecture and RANMO based setup being already taken up by Mythili. I will skip over this, go into sample 5G use cases, what we had already tested in this setup, and that can possibly give you an idea of how you can use this for any of your use cases. And also we'll talk about how these applications can connect to through this 5G setup to to run your various applications over it. And also finally we'll touch base on how can you use this 5G testbed, like how do you access this 5G testbed, which is already in a shape usable for you. So going over it, I think the first overall end-to-end setup, this is with the RAN. I think this is what Mythili had already talked about, where you have any of your applications which you can put it on this side and then put your servers on the other end of the core, and you can use this entire part as one 5G pipe to connect your application. So here you get an advantage of the actual G node B, and you have the radio part of it here, which will be like a exact actual 5G system. But then it takes time for us, like it's not right now immediately available. So we propose another feature. Okay, this is some of the end-to-end features which have already been covered by Mythili, so I'm just skipping that. So we'll get into the emulator base, which is immediately available, that has been tested for various applications. So if you look at it, the only difference that this emulator setup is making is that it doesn't provide you the radio related variabilities that can come, but it gives you other advantages that you can initially start with this, which is immediately available, wherein your applications can directly be interfaced to these UEs, and you can test an end-to-end kind of flow with this as a 5G path. Later, when you move into the actual system, whenever the actual system is ready, nothing changes because these interfaces will be maintained exactly the same even there. So that's the advantage that you get in using this. Another advantage that you will see is you can emulate multiple users, like more, like if you're talking about IoTs where you want thousands of UEs or more to be emulated. So RAN emulator provides you that kind of interface, which in actual system might be something difficult to do. And also it gives you an advantage of using multiple access nodes. Like you can use multiple G node Bs, multiple N3 IWFs, and have a mixture of that also. So that is what the RAN emulator would offer now. So it is immediately available. It's already there. We have already tested some of the use cases on this. And as I said, the interfaces of the app or the server will remain the same even when you move into the actual system later. And it can emulate multiple UEs and access nodes. But only thing is that it has a limited radio behavior emulation. And if that is not really something that is you need it for your application to be tested initially, you can ignore it, go with it, and then the variability that would come later with the actual system will only be the part of radio. And it has a GUI based interface for a convenient usage. Like you can configure what you want to set up, what is the kind of requirements that you have. You have a GUI that will help you to set it up. So now let's get into some of the sample use cases that we have already tested with this setup, RAN emulator with core setup, so that it gives you an idea of what can be the kind of your use case which matches any of it. So we have taken wide category of use cases so that you can try mapping any of yours to any of these which have already been tested. First is video surveillance, like we connect an IP camera to the UE, and then the live streaming from the video from the camera can be routed through this 5G testbed. And if you have any servers which is going to look into these or process these streaming information and is going to take some decisions on that, then you run the server on the other end. I have pictures that will explain you. I'm just giving you an overall idea here. We look into in detail how do they work in the subsequent slides. So we have tested these video surveillance live camera. We have also tested a few IoT sensors, like we have tested one temperature sensor connected over a Raspberry Pi towards our RAN emulator, connecting to any of the cloud applications where these sensor informations are being pushed, processed, and taken up. So if you have any IoT related applications, it is possible. And other is a simple app server kind of thing where you have some applications which need to run on the thing, taken over a standard 5G pipe to a server on the other side where you do. This is a generic form, like any generic kind of application that you want to test or say that it is being run over a 5G testbed, then you can use that. Other one, next one is a internet connectivity. So we do have a setup where we can have an internet connectivity provided. So if you have any of your servers running somewhere in the cloud and you have an application to connect to it, it will still be possible when you connect over the 5G testbed. So using this basic internet connectivity that is there, you can try or check your applications on that. Other one is edge processing. So edge processing, and let me just quickly say, like if you have servers which are somewhere on the cloud, and if they are very time sensitive and you want them to be placed as closest to the base station, that is what this edge processing provides you. You can have a server which is locally put up very close to the Gnode B or very close to your processor, I mean the access node, so that you have shorter processing path, I mean the time delays to reach the server. So, and you can also do a dynamic switching, like for example, you have something to be typically routed to the cloud, and based on some decision making, you decide now, okay, let me start moving the data to a local processing or something. Like you have a downlink happening from somewhere, and then you see that there is a local server which can give a faster access, then you move the traffic. So these kind of runtime decisions are also possible going on this. So this is one kind of typical use case that has already been tested on our 5G setup along with the RAN emulator. So these are very generic categories of use cases that we have. So maybe any of your applications can fall under any of these. Apart from these, if you have anything else, we can discuss on that. But these are typical use cases that we have already tested with our RAN emulator. So I'll just run over each of these in detail now. For example, now this is the exact use case where we had a surveillance camera connected over Wi-Fi to the RAN emulator, one of the UEs, and then the data path was switched using over the UPF through the internet, where they had running the video server somewhere in the cloud in the internet. And now this is like we had a corresponding application provided by this same service provider of this particular video camera on a 5G on a normal mobile, wherein this you can view this over the same RAN emulator setup. So what we have done is like we have set up the upstream using this Wi-Fi connectivity to the RAN emulator controller, wherein the video is being uploaded towards the video server through the RAN emulator and UPF part of the core to the video server, and then viewing of that, the live viewing of that on the downlink to the mobile, also connected through the same setup. So this is one typical use case wherein there are a lot of use cases where people are talking about like video surveillance on the roads, on any industries where they want live upstreaming of the video, and then monitoring of it from somewhere, anywhere in the cloud. So this is one thing which we have already demonstrated, which is working fine over this. Then to move about into the next one, so this is another IoT related. So where we had connected a sensor, which is a temperature and humidity sensor, and we connected that over a Raspberry Pi board connected through Wi-Fi to the UE emulator. And again, we have some software running here which will monitor this and push the data towards a server running on the internet. And so the data has been available here for the processing. So if you have a similar kind of IoT kind of applications where you have some other sensors or any other things to be interfaced, we have this also available to be used over this RAN emulator 5G core setup. So this is one simple use case that we have done, but we can expand it for other use cases if you have. So here the advantage is you can have multiple such sensors connecting to different UE emulators. So if you want to emulate multiple IoT devices, that is still possible by this interface. We've just shown one, but then you can expand it for multiple and then test your server for behavior of multiple UEs. So this is one interesting use case. Then going over it, so this is what I'm talking about is like you have general internet connectivity available. So if you have any typical internet based apps that you have developed, wherein you have your internet server somewhere in the internet, you can still use the 5G testbed to test this connectivity through 5G. And then, so this is a basic requirement. Even for any of these earlier ones, this basic requirement of internet connectivity is there. So this, I'm just saying, there are any standard apps where the server is running in the internet, you can still use this to test over it. And next is this edge, whatever I was talking about. So if you have some clients wherein you have two parts, like one, like you have some central cloud where this client typically connects to, but then based on your decisions that are being done here, if you want to runtime, switch the traffic to a local edge processing unit. So that is again possible, which has been already tested as one use case along with another partner of ours who are working on this MEC orchestrator and other things. So this as a setup we already have tested. So if you have any specific use cases to test over these kind of processing, which can still be planned, we can work out that part of it. And so these are some of the basic use cases which we have already tested. So just have a check if any of your requirements fall under any of these categories. We can take it further and then see how we can use this 5G testbed. So moving forward now, let's check out what are the connectivity options that you have for your application to connect to this UE emulator part. On the other side, it is very standard. It's an IP connectivity on the core side. When we talk about this side, right? This side, wherever you're going to run, either you're going to have your server somewhere in the internet, or you can have it as a server outside this 5G core on this is a standard IP connectivity that you can connect to the 5G core on this side. So this is a very standard interface. But what we need to check out is this part of the interface, which is very application specific, and how do we interface. So that's what we will look into now, as to what are all the options that we provide currently for any of the application to interface with the RAN emulator. So here the UE emulator is a part of the RAN emulator, which is emulating an UE as if an actual UE you're interfacing with. So let's look at what are all the options that we have here to connect your app. So again, here we have two categories of app that we are talking about. Some of these which are legacy apps, which don't require any specific changes or doesn't have any specific 5G related requirements to be put in, then those come under the legacy app and they can directly interface, wherein the control is not taken up here. It's only the data path that we will directly take in. So we will set up a data path and provide data interfaces here to which the app can route the data, and we will be taking it in. And the other category that we are talking about is 5G aware app, wherein it needs some of the 5G features like setting up 5G QoS, asking for specific QoS that the 5G can provide. So in these cases, we assume that the app is able to interface or provide the control. So this blue color line that is indicated here is a control path, wherein it can specifically ask for some of those features. Like it says, I need a data path with these parameters, these QoS and all that. So for this, we have developed and we are developing in a 5G aware API, which will be provided as part of this RAN emulator interface, which can be integrated to this app, and then using those APIs, the application can request for 5G specific parameters. So this is something that's ongoing and maybe available in a month's time, wherein the other part of it is already available. Immediately it can be started, but this will take a month for you to. So if you have very specific 5G related parameters to be set up, and then using different QoS flows, different even servers within that, then that is possible using these APIs. So these are the two major categories of applications that we talk about. The legacy app, which can just route in data. It doesn't care really about asking for any specific control path. The other one is a 5G aware app, which can ask for specific 5G things and then also route the data towards the UE emulator. So here, if you look at it, we are talking about one setup, one option, wherein the application can run along with the RAN emulator in the same machine. So here, our RAN emulator is a Linux based system. So the application also should be a Linux runnable one. So in case you have applications that can run on a Linux machine, then you can run it along with the RAN emulator in the same machine, and then you can route the data through that. So this is one option. And going forward, if in case yours is not a Linux based but an Android or any other OS based application, then also it is fine. You can run them on whatever machine or system that you run your app, but you can still interface with the RAN emulator. We have data interfaces open, which can be conveyed back for the app to route the data in case of legacy app. And anyway, on the 5G aware, the APIs are like a REST interface based, so you can run them over any of the IP interface and then request for it and then route the data. So we have talked about two options. One where the app can run in a Linux system itself along with the RAN emulator, or it can run on an external machine, which can be a Linux based or an Android based or any other, and they can still interface with the RAN emulator to initiate the connectivity. So this is other option. And other way is also like we have already tested the applications on a Raspberry Pi. So if you have a Raspberry Pi based applications which you still want to connect to the 5G system, that is still possible. So it's the same thing there also. We have both the options available. It can be a legacy app or it can be a 5G aware app which can interface to the RAN emulator. You can either connect it over Ethernet or connect it over Wi-Fi. Connectivity towards a RAN emulator, both options are possible. But the actual application can be running on the Raspberry Pi. So this is more suitable if in case you're doing any IoT kind of thing where this Raspberry Pi can work as an aggregator of multiple IoT devices and then take a single pipe towards the 5G code. That's also another option that's possible. You don't need to connect multiple IoT servers directly. You can have an aggregator which can even do that. So Raspberry Pi, typically we have seen people using that as an aggregator and then used to connect to the 5G system. So this is other option that we have. So I think so that's all this. So these are the various ways by which you can connect your application to the RAN emulator, either on the same machine or on a different machine on a different OS or on a Raspberry Pi towards the RAN emulator. So these are the connectivity options that we have. If you have anything other than that, we can discuss it. But then if you can map it to any of these, then it is readily available, which you can take it up. So then the next question comes in, how do I use this 5G testbed? So currently, we are ready to set it up. We can do it as a local access where somewhere in IIT Bombay or in in CEWiT or in IIT Madras interface, we will have an end-to-end system along with the RAN emulator and with the 5G core and with the other connectivity options will be set up, wherein you can come to any of these setups and then use them locally. We are also trying to work out remotely accessing these from any of the Indian institutes using the NTN part of it. So all those details we will let you know like no, again, it's based on the interest coming from the from this team, like how many of you want to use it and how do you want to use it, based on which we will work out how we can do this. So, but options are available to do it either locally or to remotely connect it. But then how and when the actual modalities can be worked out based on the interest and request that is coming from this group. I think that's all I had for this. So if there are, I think after this, we have a question answer session where we can take it up. Thank you.
Thanks. It was really very insightful, and thanks for really sharing the use cases. I think I'm sure people would have gotten the feel of how they can possibly use it. There are some questions you may want to possibly take it. Few questions.
Yeah, hi. This is Avinash here, Avinash Kamath. So we definitely want to use the testbed. So how do we indicate our interest to use the testbed? Will Incubate Hub be asking that, collecting that information, providing to you, or do we? I mean, how do we? You know, pass on our interest, because you said that depending on the interest, you will make the testbed ready. So just want to understand the process to get that done.
Yeah, okay. Would you like to take, or I think?
Yeah, I would like to take that. Avinash, I believe last week we have shared a Google form link where you can fill out certain details which will help the authorities understand what kind of support you need. In case you haven't received, please let me know. I'll have it sent over to you, but please have it filled today. I think today, and the DOT authorities, and then they'll be forwarding it to Mr. Babu and Chandrasekhar and so on.
Okay.
So I hope you did get that email.
Yeah. So that is already filled up. So okay. So if that is the way to request, then I think that request is placed already. Yeah. Thanks.
Yeah.
I mean, this is Abhijit here. I had a very specific question, like probably most of the all of the guys have, is that do we need to be physically present to access the testbed? Because it seems that it requires some amount of Wi-Fi connectivity to be connected to the emulator, or it can be accessed entirely remotely.
Maybe I can answer that, Babu here. See, just let me kind of add on top of what Anu had talked about the connectivity. Anu had put up and showed Wi-Fi as a connectivity between the external third party or an external device to the U emulator. It need not be only Wi-Fi, it can be any IP connectivity over Ethernet, wireless, as well as wireless or Wi-Fi. So with that, we should be able to have some network connectivity towards an emulator, that is a U emulator, from any other machine. So what, as Anu said towards the end of it, what we'll work out is perhaps we'll have a system. We'll have to look at two parts. I don't know how your use cases would be. In one case, where we can have a machine that we arrange in our lab as the user machine, which then can be connected to the RAN emulator, and the user machine, you can log in and do whatever you want. You can install your application and so on. But if we have a specific hardware that you want to connect, then we have to look at how we can connect. Suppose the device is in your lab and you want to connect that to the RAN emulator in our lab. Then we need to work out how kind of efficient can that be, as if it is an external application sitting in somewhere in the cloud and still connecting through 5G to the other side of the network. Does that answer your question? Yeah.
So yes, it does. I mean, so for that, what information is required to sort of get access to that, or
I'm sorry, hear the last part.
Sorry, I mean, I meant that how do we get access to that? I mean, as you mentioned that you have to mention, fill out a form, right? Or is there anything else that is required to access this for our use cases?
Yeah, so based on individual users that we collect using these forms, then we can work out the individual setups. So I'm understanding that the setups, the requirements will be different for each of the parties.
Correct.
So you may have to look at the diverse requirements and see how to meet each of them.
Okay, all right, sounds good.
Okay, thanks, Mr. Babu. I think Mr. Babu has also answered some questions in the chat itself.
If there is anything that is still not done, I can look at that. I'm trying to see now. Maybe I don't know where to start with.
Yeah, there was one query regarding like, where do we get these APIs? So APIs we will publish as part of this RAN emulator setup, which you can take it up and then use it for interfacing with your application. So it will be a standard REST API based interface wherein you can use these, build your connectivity using these APIs. So these will be given as a document format as to how these interfaces are. This will be published along with the RAN emulator, which you can use.
Any other questions if we have missed out, please feel free to unmute yourself and ask. I think someone was trying to make up.
Yeah, so we may not have gone through all the questions on the chat. So if somebody has put it up at the bottom.
Hello, Nandakumar here. Hello, can you hear us?
Yes, yes.
Actually, if you want to showcase on edge use case like MEC, our applications are available on edge, and we need to. Can we know what is the configuration available? So I can install applications on an edge node, or I can. I need to go for through cloud architecture. How you say for edge nodes?
So if I understand your question is how to set up
edge node, yes.
Edge node, right? See,
yeah.
For us, as far as 5G network is concerned, whether it's cloud or edge, is an exit of the traffic from the network.
Okay.
So what you can define is to see where to exit. Because as you have seen in the diagram, what Anu had shown, the exit can be near to the base station. The traffic can exit from there. IP traffic can exit from there to the edge server, or it can exit from any other point in the cloud towards the central server. It is for you to configure that. So one thing which Anu would have mentioned is that there is a possibility that the application function can also influence that. For example, you can say the exit should be through so-and-so access interface. That is an extra control that 5G provides to the application function. Correct. So just as she was talking about the client-side connectivity, on the server-side connectivity, an application servers can request, can send a specific request. It is as per the 5G standard itself. It's part of the 5G specs. If you are able to program the application function as per the 5G specs, you can invoke a service, what we call as a network exposure service. You can invoke the service and provide the traffic influencing parameters to the network, which in turn it will use to direct the traffic to appropriate external servers. So we can provide that information also if you want to do that level of control from your application function.
Okay. Okay. So if you want to connect, to discuss more on this, whom to connect?
So for all this, as Nachako was saying, once you collect the forms, we'll have interfaces defined, some contact person defined for discussing each of your use cases.
Okay. Okay. Fine. Thank you.
Yeah, I think Kshitij also had a question. Kshitij, you would like to unmute and ask, or I can read it out? How can a cloud service be included in the testbed? If not possible, do we have to shift server infrastructure to host our website or Android application? That was a question from.
Hello. Good morning, sir. This is Kshitij.
Go ahead.
Sir, actually, I would like to know that if we are using any cloud service, like we would be hosting some of our algorithms on the Azure cloud or the AWS cloud, we have to decide about it. If we are using any cloud service, So how can we integrate it into the 5G testbed, or do we need to use your any specific cloud setup?
Okay, so if I understand your question, the use case, you have an algorithm running in the cloud, and a user equipment or a device will be using that algorithm to run some function, right?
Yeah.
Is that so? Is that the use case?
Yes, sir. Absolutely right.
Okay, so yeah, that is one of the definitely a good use case to look at, where we can have the 5G network which connects a device on the RAN emulator side, on the UE emulator side, to the cloud on the network side, that is towards N6 interface we call it, which is exit option from the UPF. So as a immediate comment, I think this should be possible, though we have not checked it out. We can work it out and see whether how to set this up. And I don't know, Mythili, if you have any additional comments, you could indicate.
No, I think that is fine. I mean, we can treat the cloud as any other internet server, right? That should be possible.
So,
yeah, I don't see it. Yeah.
So would you suggest that for the time being, for the test bed, should we shift to a standalone server service or anything kind of that thing, or we can
That is
continue?
not needed, right? See, I mean, if your goal is to just test the algorithms, you probably don't even need to go through the test bed.
Okay.
Right, but if you can just test your algorithms on the cloud that way, and the test bed is only for connectivity. So you can, for example, if your client side can directly talk to the cloud servers and get your algorithms tested, that is fine. But if you want to test the 5G connectivity, then you go through the 5G test bed, and we will on the internet side we will connect to the cloud.
I think if I understand, actually, if your use cases where in the future when you have a device and you have an algorithm which requires a lot of computing and not possible to run on a device, you want to run it in the cloud and have a kind of a low latency, fast interactions between the device and the cloud to service some 5G services, right? Okay. So you can use this, yeah, you can use the setup to show that through an emulated 5G testbed that is possible.
Okay, so any 5G network can connect to any internet server on the other side. It can be a local server hosted or cloud or what, doesn't matter, right? I mean, we will provide connectivity to whichever network on the other side.
Yes, ma'am. I had only that much doubt because my hardware connectivity, how you're going to integrate, that was clearly explained here. Only the other part where my website or my application user was going to use, only that was the confusion which has been cleared. Thank you very much, ma'am.
Okay.
Sir, I have also a question on similar line. Actually, we have a application which we are going to deploy on one virtual machine. You may consider it as a server. And at the client side, the user will open the browser and access the server that is hosted on virtual machine. So basically, server and two different client. So my question is that the whole thing we have to deploy on the 5G testbed, or our server will be deployed at one particular server over the internet, and then client will be at your 5G testbed. So that thing I want to check with you, that the whole system we need to deploy at 5G testbed or something like that.
Yeah, here again, if I understand, your server will be located in your private lab. So unlike the earlier case, we are talking about Azure, where it's a public cloud. You have to look at some way of reaching out to your lab from the 5G exit point from our lab. So that routing we have to ensure. Either you look at a VPN or some other mechanism to reach out to your server from the 5G testbed lab.
Okay, thank you.
Hello. Good morning, sir.
Yeah, good morning. I can hear you.
Sir, actually, we are having an application based on NB-IoT protocol using 5G. So in the website, it is mentioned that by 30th of June, we need to submit something. So my question was, what actually we need to submit? Is it some video or video of our whole product or some product, physical product which we need to submit?
I suppose Uday or Nachappa can answer this. I'm not aware of this 30th June.
Sorry, sir, it is not audible.
Actually, you're not audible. Hello?
Am I audible now?
Yeah.
Hello?
Yeah, I just wanted to hear the question again based on that.
Can you repeat the question? I think I also wanted to understand the question.
Okay, sir, actually, we are having application-based use case for this 5G hackathon using 5G NB-IoT technology. So we are having our application, and in the website, it is written that by 30th of June, we need to submit the product. So we were confused whether we need to submit the product physically or just to show the video recording of the product or some demo kind of things.
It will be demo, but off the record, as Mr. Patakji mentioned, we may have an extension based on the current situation and restrictions due to lockdown. But it will be a prototype of sorts where you will have an application to fill out about your product and then also do a demo. Whether it is in physical or online, that will keep you posted.
Okay, sir. Okay. Thank you so much, sir. Thank you for the clarification.
Okay, I think if anyone has any other question, request to unmute and ask, please.
Hello.
Yeah, go ahead.
Yes, sir. So we have developed an application which is running on the Raspberry Pi, and we will be mounting the Raspberry Pi in a drone. So the drone has to be connected with the 5G network. How can we connect it, sir? As of now, all the applications which have been mentioned is connected through Wi-Fi. So we want to connect through 5G network, and we want to control the drone over the 5G network. Is it possible to do it in the test bench? Test bed.
So if I understand this Raspberry Pi is your interface towards your drone, is it? Or is it directly going to connect to the 5G test bed?
We have developed the application and put it in the Raspberry Pi, ma'am. That Raspberry, as of now, we are using USB dongle, 4G USB dongle to connect to the network. We have our server. So from the server, we'll be giving commands to the drone and the drone will be flying. So we want to replace that with the 5G network. So how to do it?
Yeah, so that whatever the 4G dongle that you use, instead of that, you can connect your Raspberry Pi to the RAN emulator, and the same kind of interfaces, similar one can be used to connect to RAN emulator, and so the path will be set up and you will be able to still do the same control from the other end through the
I think maybe to add to that, I think if I understand the current connectivity from drone itself is on 4G.
Yes, sir.
Directly,
yes, sir.
yeah.
Yes, sir.
That is where that dongle also supports a modem functionality.
The drone
LTE modem is part of the drone itself.
Yes, sir.
So actual total replace equivalent of that in 5G would be where you also have a 5G dongle, a NR modem on your drone.
Okay.
I would say that is a little down the line. We don't have such a kind of product now.
Okay.
I'm not sure outside, but currently it's not there in our testbed anyway.
Okay.
So for you to connect, you will have to have a mechanism of connecting the drone to another 5G CPE or a 5G system on the ground.
Okay.
That which
so,
for that
Babu,
you had
I
to
thought
use.
that's what the Raspberry Pi is doing, right? Like
no, he's talking about Raspberry Pi directly having a 4G dongle inside. So Raspberry Pi directly talks on LTE.
Yes,
there is
yes,
no
yes,
Wi-Fi.
sir.
Yeah.
Yes, yes.
So there is no equivalent.
Your drone to the Raspberry Pi, what is the connectivity?
The Raspberry Pi will be on the drone itself.
On the drone. See,
Okay.
Yeah.
Sorry. Then I think that part I missed. I thought it's like drone is a separate entity and
no. The Raspberry
we have which is the Raspberry Pi.
We have done the programming such that the Raspberry Pi controls the drone. So we'll be giving the commands from the ground station. So Raspberry Pi receives it and processes it and flies the drone.
Oh, okay.
It's a good option. I think it's a good use case. I think future will be one of the use case for 5G will be that. But again, as I said, for that you have to have modern chip which can be put onto the dongle or onto the Raspberry in future. Currently, that option is not available. For you to look at as a second best option is that what I said, you have to have a wireless connectivity, which is the best suitable currently is Wi-Fi. towards a 5G CPE or a system which is on the ground. And then, of course, you take to the 5G pipe. Of course, it is not the same as what you have now. Yeah, but then you have to take a call on that.
Okay, thank you. So to further have discussion with our application, to whom should I contact, sir?
Yeah, I think that's
Because
already be a discussion. Once you put all these forms and we get that, we consolidate, we can have somebody allocated to discuss further with you.
Okay, sir. Thank you so much, sir. Thank you so much, ma'am.
Good morning, everyone.
Hello, ma'am. I had one question. So my question is regarding, sorry, the IoT use case. So you say that if I consider the Raspberry Pi, so it is connected over Wi-Fi to the 5G testbed. But suppose I want to connect the 5G, like IoT sensors to cloud and cloud to the 5G testbed. So is there any specific cloud service that I have to look into, or like the existing ones like Microsoft Cloud Service or Amazon, they will also work? So if you kindly guide on that part.
I think any of the existing cloud services, because that I think 5G test is transparent to these servers that are being used at the application level.
Okay, ma'am. Thank you. Thank you.
Hello, good morning.
Yeah, go ahead.
See, I came across some of the trials done in the, like, as you said, you tried some use cases. So I like to know the test results, like you said about the video and data transfer. So is there any test results of this? And, is there any information that, what is the ping time or latency achieved in these test cases, so that we can compare our use cases with what is tried on the 5 test bed?
So in any of these use cases, we haven't still measured the end-to-end performance or whatever the parameters that you're talking about. Right now, we don't have, but then we are working on getting these and displaying them per application. So maybe in a month's time or downline, we might have it, but currently we don't have in any of these use cases, those specific performance parameters being measured end-to-end.
May I add to that what Anu said. In fact, for an emulated setup, those may not really matter much for the reason that it's all running on IP networks. As such, the capacity supported by the 5G network, emulated 5G network, will be quite good. It can be order of, based on the kind of network cards you have, can be at tens of gigabits, and it's even with 1 gigabits much more than what required for any typical such an application would require. So as for the throughput and latency, you may not really see the performance of an emulated setup which can be comparable and seen whether there is better or worse than an equivalent field setup. I think for that, the best is to wait for the hardware-based RAN to be ready to get a real picture of the performance aspects of 5G.
Okay, thanks. Akshat, would you like to quickly ask? I know we are overshot on time, Mr. Babu and others. Is it okay to take a few more questions, or we should connect offline? There are some questions. Akshat has some questions.
We can take 2-3 questions, and if I am okay, Mythili, Anu, are you okay?
Yeah. Let's take the questions. Yes.
Thank you so much. Yeah, Akshat is saying that is it possible to connect any microprocessor with 5G testbed, and is it possible to use Node MCU with 5G RAN emulator? If we are using a combination of Arduino as microprocessor and Node MCU for Wi-Fi, is it possible to connect this with RAN emulator?
I think to many of these questions, we can give a generic answer. Again, taking from whatever Anusuya has presented. Any external device, any kind of hardware, it has no limitation on the platform, the type of platform. Anything that it supports IP and Wi-Fi, Ethernet and Wi-Fi, it shall be possible to connect that to a RAN emulator or a UA emulator of a RAN.
Right. Thanks. Yes, otherwise we seem to have covered most of it. I think, obviously, I think we also answered about the NVIDIA thing. It was the same question related to IP. So, yeah, just in case anyone has, I think there's a one more new message. No, not a question though. Just that there's a thank you from. Okay. Thanks, Mr. Patel ji, if you would like to just give your closing remarks, please.
Yeah, sure. Thanks.
Thanks,
So,
thanks. Mr. Babu, thanks, Mr. Babu. I think.
Yeah. Sure.
Yeah. And
I'll just give a brief summary.
Please, Mr. Babu. I think you were to summarize first. Yeah, please.
I'll just give you this when summarizing whatever has been talked about by Professor Mythili and Anu. Is that now the 5G testbed that we are building has two flavors. One is a hardware-based, RAN-based one, and then an emulator-based one. The RAN-based one, both are being developed in parallel. 5G core is common to both, but the specific G-Node B is part of the hardware-based, and equivalent one of that is an emulator in the RAN emulator. In order to again make it fast and have some of the application tried out, the emulator-based setup is being being ready first. It's also easier to make that ready because of its software-centric. In fact, for the hardware-based testbed, we had delays because of Corona. Corona had a huge impact on our testbed also, both wave 1 and 2. Even the wave 2 has really impacted the team members and the work as such. That is one reason we are not able to, though we had planned to get the version completed by April-May timeframe, got delayed because of that. So now we are pushing it to another 2 months down the line to get the hardware-based setup ready. So in the meanwhile, we thought that emulator-based setup, which gives much of the functionality, and as Anu said, interfacing towards the testbed is the same, irrespective whether it is hardware-based or emulator-based. So that will help users like you to connect it and then check it out. And once you check it out, the emulator, and later on, once the hardware-based is ready, you can even move on to that and further kind of run it on a hardware-based testbed. So that is one major kind of a point I want to highlight. Both of these are kind of ongoing. As I said, its target is around October. We have two versions, V2 and V3 towards the later stages. V2 is more or less complete, and V3 is the final version, which will be readied in September-October timeframe. When we give this emulator testbed, the V2 version is what we are opening up for usage now. In terms of features, I think already covered some of the key features. I think you would like to look at is in terms of the QoS, 5G QoS, which will be more related to whether it is EMBB or URLLC or IoT. In our case, since we are having only NR-based thing, all our use cases also will be NR-based, which is primarily we are focusing on the IP sessions. That's why we are telling that any external device which has an IP connectivity, we can take it through 5G as an IP pipe. And that is the most used, that will be the most used use case for 5G in future also. The NB IoT part, the specific, the very kind of specific to IoT, that part will be ready much later. That is more of a hardware-based NB IoT setup will be ready in 2-3 months down the line, along with the NR-based setup. And then you have the other functions we talked about, like edge or traffic influence or slicing, which you will be able to use it if it is part of your use case. And since we have discussed a lot of these type of connectivities, and many of them could be specific, like each of you would need a different kind of connectivity. We have to work out how those can be realized in the actual lab in the testbed. So that will work out in the coming weeks. So suppose that all this information will be useful to you and sufficient for you to at least look at whether the testbed will be useful for your use case, and then how you'll be able to utilize it for realizing your demonstration. So thanks a lot from our side.
Thank you. Thank you, Mr. Babu, Mythili and Anusuya. It was really very insightful, and I think we are getting a lot of appreciation. And I mean, thank you from the whole participants over here, and look forward to really transforming this whole 5G space. And I think this will be a genesis of a big future for 5G. I'm sure, leveraging this test bed. It's really appreciable, Dr. Pathak ji, if you'd like to just give closing remarks, please.
I'm not sure if he's there.
Okay.
Can't find him. So I think Mr. Babu summed it up really well. We have posted all the speakers' email IDs on this chat, and we will also post it on the website. So if anything else is needed, participants can reach out to them and get all the information.
Correct. Thanks.
Yeah, thank you, everyone.
Thanks.
Thank you, Alia. Thank you very much.
Yeah, wishing everyone
you.
all the very best in your development and submissions. Look forward to engaging. Bye.
Yeah. Thanks and all the best to all the participants. Bye.
Look forward to all the support from the test bed team.